The question is simple. What is the width of this piece of paper? Your hypothesis will probably be the same as mine. It's 8.5 inches wide, which, because we are in physics and we like the metric system, we'll have to convert into metric and express that in meters or centimeters. But that's your hypothesis. And so now, to test it out, you need to measure the width of the piece of paper. So to do this, and I specify this in the lab, I want you to record the width of this piece of paper to 4 decimal places. So in order to do that, you're going to want to take your piece of paper and place it over your meter stick, or place the meter stick on top of the piece of paper, something like this potentially. And I don't want you lining up the edges. No, like putting it exactly at the 40 centimeter mark or something like that, right? I want you to just move it around randomly, boom, there you go. And set it so that it's square. And I want you to record the location on the meter stick of the left side and the location on the meter stick of the right side in the data table. That's XL and XR. And then you'll subtract those two to find the width. And again, I want you recording this to 4 decimal places. So I'll give you a quick example. I'll hold the meter stick up here and we'll do this one together. So I hold this up and we look. If we want to look here at the right side of our piece of paper here, I'm going to put it on top because it might be easier to see in the camera. We're going to put it at some random location. We're not going to line it up exactly. So if you look, we can see the 47 centimeter mark, but not the 48. So in meters, that would be 0.47 would be my first 2 decimal places, 0.47. Then the next one is how many of those tiny little millimeter marks we see. All right, so I'm looking at it through my camera, but I think that there's 4 visible. Yep, it looks like there's 4 millimeter marks. So my next decimal place would be a 4, so 0.474. And then the last decimal place is an estimated digit. So you have to look at where that edge is and estimate on a scale of 1 to 10, how far is it between those 2 millimeter marks. If you look at it, to me, it looks like it's just the slightest bit past halfway. So I would estimate 6 as the next decimal place. So for the location of the right side of my piece of paper, it's going to be 0.4746. Then, holding the paper tight, making sure it doesn't slide around, I go to the opposite side and do the same thing here. Now, we notice the 69 centimeter mark is the last one covered. We can see 70, but not 69. So again, it'd be 0.69. Then we have to look at how many little black lines are covered. I see 8 of them. That means there's 1 covered. So 0.691. And then again, estimated on a scale of 1 to 10, if you look, it's almost all the way. So I might estimate 8 as my last digit. So 0.6918 would be the location of that side of the piece of paper. I subtract the 2 and that gives me the width. Then I take the same piece of paper on the same meter stick, move it to a new location and go again. Move it to another location, go again. Do that 5 times. Then switch and make sure there's not an error with the tool and do the same game with a second measuring device, like this other ruler here. And you'll do that 5 more times as well. Again, every time I want you measuring to the 4th decimal place when measuring in meters, or if you're in centimeters, the 2nd decimal place.